Good morning, HOD Professor A.K. Chaturvedi sir, my seminar guide Dr. Brijesh Tripathi sir, seminar coordinator D.P. Sharma sir, faculty members, examiners and my friends. I am Shubham Joshi pursuing my Bachelor of Technology from University Department of Mechanical Engineering Rajasthan Technical University Kota. My seminar topic is solar air heater. This is going to be our list of contents. Firstly, we talk about history of solar air heater. In theory, solar energy was used by humans as early as 7th century BC, when history tells us that humans used sunlight to light fires with magnifying glass materials. In 1839, Edmund Becquerel discovered about solar energy and becoming the father of solar energy. George Locke, who built solar heated air system for a house in Boulder, Colorado in 1945, he later included a gravel bed for heat storage. Now let's come to know the definition of solar air heater. A solar air heater is a type of solar thermal system where air is heated in a collector and either transferred directly the interior space or to a storage medium such as a rock bin. In other words, we can say solar air heating is a solar thermal technology in which the energy from the sun insolation is captured by an absorbing medium and used to heat air. Solar air heating is a renewable energy heating technology. Now we are talking about various types of solar air heater. The first one type, which is most commonly used in many applications of heating, is flat plate solar air heater. Flat plate solar air heater and other types are unglazed perforated solar air heater, transpired solar air heater, thermosophin air heater, heat recovery ventilation HRV solar air heater. Number 1, plate solar air heater. This type of solar heater have been employed for the space heating, drying and similar industrial applications requiring heated air at low to moderate temperatures. The unglazed transpired collector is relatively new solar technology that was developed in 1980s for ventilation air heating. The absorber part of unglazed transpired collector is perforated so that ambient air is continuously withdrawn through the perforations. Now we are talking about working of solar air heater. In this order, firstly, solar radiation energy from sunlight comes to the on collector plate. Then the solar air heater works by drawing in fresh outside air and circulating through a maze of black aluminum that has a special selective coating that absorbs much more heat than it emits. Only solar radiation enters in the chambers. Fans pulls the cool air from the inlet. After that, this cool air gets heat energy in chamber. Insulated layer is attached in bottom to avoid the problem of heat leaking. In last step, hot air is outed from outlet with help of blower to the wanted place. It consists of 7 components which are shown in diagram. At entering point, inlet duct; at exit point, outlet duct; top side, absorber tray; glazing; rigid frame; in bottom side, insulation; and wooden cabinet is used for a complete solar air heater basic structure which is shown in figure on slide. Use of fins on the absorber plate and different surface geometry of absorber plate enhance the rate of heat transfer during the sunshine hours. And use of PCM, thermal energy storage medium, supply heat energy during off sunshine hours. As a result, solar air heaters gain popularity in a wide range of its applications. Now we are talking about enhancing performance of solar air heater. First one is by adding aluminum chips verticals in vertical solar air heater, paraffin wax and nano silicon carbide vertical tubes. Second is increase the collector absorber area by using phase change material PCM. Paraffin is most common used PCM by increasing ambient temperature. It is found in an experiment that ambient temperature rises to 278 to 288 Kelvin. Efficiency increases by 7.5%. These are the main difference between solar and electric air heater, which are shown in table on slide. Now coming on application of solar air heater. Number 1, industrial purpose. Number 2, drying agriculture produce. Number 3, heating greenhouses, household purpose, and last, commercial purpose. A picture on slide which is taken from a manufacturing plant where solar air heater is used to with complete setup. Now advantage: the need to transfer heat from working fluids to another fluids is eliminated as air is being used directly as the working substance. The system is compact and less complicated. There is no problem of corrosion in solar air heater. No problem of leakage of air from duct solar air heater. Freezing of working fluids virtually does not exist. The pressure inside collector does not become very high. Solar air heater is comparatively cheaper in cost as well as less material. Air heaters have certain disadvantages also. The first and foremost is the poor heat transfer properties of solar air heater. Special care is required to improve the heat transfer rate. Another disadvantage is the need for handling large volume of air due to low density. Air cannot be used as a storage fluid because of its low thermal capacity. In the absence of proper design, the cost of solar air heaters can be very high. There are some reasons for increasing future scope. They are number 1, continued government support, incentives and policies promoting renewable energy and sustainability may further drive the adoption of solar air heater in the future. Environmentally friendly solar air heater do not produce any greenhouse gas emission or air pollution during operations, helping to mitigate climate change and reduce environmental impacts. Cost effective operations. Solar air heater have minimal ongoing operating cost as they do not require fuel or electricity to generate heat, resulting in potential energy savings and long-term cost benefits. So that was all about my seminar topic. Thank you.